This is Science Max, Experiments at Large. Science Max! Greetings, Science Maximites. Welcome to Science Max Experiments at Large. My name is Phil McCordick, and today we're gonna be building an air-powered rocket. Too difficult, you say? Nonsense, it's easy. It's not like it's rocket science. Hey, it is rocket science. Cool! Here's what you need. You need a bottle and a cork. Make sure that the cork fits nicely into the bottle, and then you need an air pump, because you can't have an air-powered rocket without air. And on this air pump, you need a pin, the special kind that you use to inflate basketballs or volleyballs or stuff like that. Now, what you want to do is push the pin through the cork. You might want an adult's help for this. Push it through until it goes through on the other side, and then make sure you get a good seal with the bottle. Now you're ready to launch your rocket with air pressure. But first, let's do a few other things. Take your cork and put it in a tripod launcher. You can make this out of pencils or anything you want, as long as it stands up nice and solidly. And then, of course, you want to decorate your bottle so it looks like a rocket. This is my rocket. Pretty good, right? So you stick the bottle on the cork like before, like that. And then you stick the pin in the bottom. And what we're gonna do is we're gonna inflate the bottle with air pressure, and then it's gonna launch. Okay, here we go. You know, rocketry really isn't something you should do indoors. Come on. This was supposed to be a field. What's going? Why are there? Oh, it's in my shoe. Oh, this will do nicely. Now, don't forget to do this with an adult, and don't forget your safety glasses. Now set up the rocket in a nice big open area, and make sure it's pointed away from you. And then what you do is you pump the air pump. And it puts air into the rocket, which pushes down on the water, which will push down on the cork, until eventually... So, be Science Maximites and come up with your own rocket design. Try different amounts of water, different fins, even a different size bottle. Try it for yourself and see if you can get one that goes higher than mine just did. How did I get in? I think it was this way. This science is delicious. This is rock candy. It's basically crystallized sugar, and you make it by turning a solid into a liquid and then back to a solid again. Here's how you can make it at home. You need a container that you're not gonna need for a while, and some water, some sugar. You can use brown or white. I like to use brown. And an adult. Here's why you need an adult. You want to dissolve 3 cups of sugar into every cup of water. And you can't do that unless you heat the water. So get an adult, a saucepan, and heat the water up, pour the sugar in, and keep stirring until it's all dissolved. Then pour it in your container and let it cool down. Then you'll need a shish kebab skewer, which is something you can get at the grocery store. Cut it down to the right size so it fits nicely into your container. And then dunk it in your sugar and get some crystals coated around the stick. These are seed crystals, and they get the whole process started. And now you have to wait for these to dry, otherwise they'll just fall off the stick when you put it in the water. So I've got one here that has dried out. You'll also want something to keep it from falling in the top of the container, so I'm gonna use a clothespin. Put it in there and dunk it in the container like that. And now for the final step, if you want, you can add food coloring. I like to use red because it reminds me of science. And I'm gonna use the stick to actually stir that up a little bit. There we go. Now, the dissolved sugar crystals in the water will slowly grow on the crystals that are already attached to the stick, and it will eventually grow into a rock candy pop. But it takes about a week. No, I'm just kidding. I've already got one that's standing by. Here we go. This one has been growing for about 7 days. And there you go, rock candy. delicious science. Tornadoes are giant weather systems that cause the air to go around and around. Tornadoes can be pretty dangerous, but they don't happen that often. Here's how you can make your own small pet tornado you can play with at home. Because air and water behave similarly, we can make a water tornado. You spin it around, get it going, and ta-da, your very own pet tornado. Here's how you do it. You take two 2-liter plastic bottles and fill one with water and some blue food coloring, is what I like to do. And then tape the mouths of the bottles together. You might need an adult to help you with this because you want to make sure the bottles are perfectly aligned. Then flip it over, spin it around to get it going, and voila, your very own pet tornado. Awesome. Today we're going to be making a gravity-powered boat. Ta-da! It's pretty easy to make. You just put water in the top here. Gravity of the water pushes it out the straw and the boat goes forward. And it's super easy to make. You only need 4 things: a piece of styrofoam, a plastic cup, craft stick, and a straw. And the tools you'll need: a pen, a craft knife, and the help of an adult, and science glue. Which is the same as regular glue, except I only use this glue for science. You take your styrofoam and you cut it into a boat shape. That requires the knife and the help of the adult. Then take your cup and draw the circle that your cup will sit in. And then you want to put 2 slashes with your craft knife in there. Again, get the help of an adult if you need it. And then start carving out the styrofoam with your finger and make a nice little indent just like this for your cup to fit in. See? And then it fits in nice and snug. So then what you want to do is you want to make a hole in the cup. You can use a pencil. The hole has to be just big enough for the straw to fit in. First, you want to take the straw and dig up in this direction so that it will be a nice angle for the water to come out, and then you want to get the straw back up into the cup like that, and then glue it so that it is not going to leak any water. And then in the final step, and this is your choice, you don't have to do this, but you can use your craft stick and you can make a rudder, or if you want, you can make a whole keel, which goes just like that, and it is right in the middle of the boat, and this helps the boat go straight because sometimes the straw goes off to the side one way or the other. Okay, water-powered boat. Actually, it's a water and gravity-powered boat. You see, what you do is you fill up the cup with water, and the gravity of the water in the cup pushes it out the straw, and the boat goes forward. And this is what it looks like in the water. You fill up the cup, and the gravity pushes the water out that way. The buoyancy of the boat keeps it afloat, and good old Newton's third law, for every action, there's an equal and opposite reaction. The water going out the straw this way pushes the boat that way, and it works pretty well. Whoa, if it's going straight. That's why we have the keel. Okay, so gravity-powered boat. This is water. Now, it's ice water. Science! Okay, no, that's not the science part. Here's something you can do at home. Get some ice water and a way to time yourself and stick your hand in the ice water. It's a little hard to stick your hand in ice water for a long period of time because after a while, it starts to hurt. But don't worry, the pain that you're feeling isn't actually because you're damaging anything. It's just your body's way to tell you that you need to take your hand out of the cold water. Yeah, you usually can't do it for very long. But some animals, like seals and whales, they live in ice water all the time. They live in the Arctic, so how do they do it? One word, blubber. Blubber is a layer of fat that protects you from the cold, or protects the seal and a whale. We don't have blubber, but we are today gonna have some blubber because we're gonna make a blubber glove. Blubber glove, I love saying that. Here's how we do it. First, we want blubber. Okay, this isn't blubber, this is lard, which is actually animal fat. You can use lard, you can use margarine or butter or shortening, anything with a lot of fat in it. And remember, this is messy, so definitely get an adult to help you. So we've got our lard, and we need a bag. So what you're gonna do is you're gonna take a scoopful of lard, like this. And you're gonna put it in the bag, like so. Like that. There we go. And then you're gonna start smoothing out the blubber or the lard like this. because what you want to do is have a nice, thin layer all the way around. See? Starting to work? Yeah. Then seal the bag and tape the edges. A square of blubber. Then do it again. Here I have 2 bags of blubber, and I've taped all the way around the outside. So I have, a blubber glove. Check it out. So let's try it out. I stick the blubber glove in the ice water. It's completely working. It is not even cold. The blubber is completely protecting my hand from the ice water. I'm not even remotely cold at all. That is very fun. So, try it yourself. A blubber glove. Today on Science Max, we're going to be harnessing the awesome power of lightning. How are we harnessing the power of lightning, you ask? With this balloon. I know what you're thinking. You're thinking, Phil, what's similar between a balloon and lightning? Well, nothing right now. But behold, as I use the power of static electricity and rub the balloon on my head. Because basically that's how it starts. You see, when I rub this balloon on my head, it's stealing electrons from me, creating a positive charge in my hair and a negative charge in the balloon. And the interesting thing is, you know that things with opposite charges attract each other, right? Something that has a positive charge will attract negative things and vice versa. But anything with a charge will attract anything with a neutral charge. See all these things on the table? They all have a neutral charge, which means they've got equal amounts of positive and negative. Right now, this balloon is building up a big negative charge, which means it will be attracted to all of these things. This can of Science Max soda, it has a neutral charge. The balloon has a negative charge, which means the can will be attracted to the balloon. And this paper is neutrally charged, which means the paper will be attracted to the balloon. And if you hold the negatively charged balloon next to neutrally charged sugar, sugar storm! And you probably, wait, I don't want to get sugar in my hair. And you probably know this trick. If you rub a balloon on your head, you can stick it on the wall. But what does any of this have to do with lightning? Well, the same thing is going on with a lightning bolt. The clouds become negatively charged, and that negative charge wants to equalize itself with the ground, which is neutrally charged. And that lightning bolt is the electricity jumping from one place to another. And you can see this yourself. If you rub a balloon on your head and you put it next to something metal, like a doorknob, there'll be a spark. But here's another thing you can do if you don't have a balloon, which I guess I don't anymore. Rub your feet, if you're wearing socks, on a carpet, and then turn out all the lights and touch a doorknob. You might be able to see a spark jump from your finger to the door. That's lightning in a very, very small form. By now, you're probably an expert on what happens when you rub a balloon on your head, right? The balloon becomes negatively charged, which means it will attract anything of an opposite charge, or anything positive, or anything that is neutrally charged, like me. Look at the hairs on my arm when I bring the balloon close. Whoa! You see, the neutral charge in my body is being attracted to the negative charge in the balloon. So if something is negatively charged, what happens if you bring something else negatively charged nearby? Well, they'll repel each other. And here's an experiment you can do to make something fly using static electricity. You'll need a balloon, a sweater, scissors, and a plastic bag out of the thinnest plastic you can find. Fold the bag up and cut off the bottom. You don't want that part. Then cut another strip from the bag. This will give you a hoop of plastic. I find it works better if you break it and tie it again. Lie it flat and rub it with the sweater. This will give it a negative charge. You'll know you've got enough of a charge when it really wants to stick to the table. Then take your balloon and rub the sweater on the balloon to charge it up. Because both the balloon and the hoop have negative charges, they repel each other. Then put them together and it will repel.
And you can get the hoop to levitate.
Ha-ha, a floating bag of static charge. But here's the thing, you need to keep it away from your body, because if you get close, the bag will stick to you, because you're neutrally charged and the bag is negatively charged. Pretty cool, right? Well, let's max it out. Maxed out floating static ring. Whoa, no. Yeah! Look out, look out! Oh, no! Oh, sorry about that. Oh well. It was fun while it lasted. I gotta charge these up again. Friction is a force that is everywhere and happens when any one thing rubs against any other thing. We do lots of things to increase friction, like wear shoes with big treads on them. And we can do things to reduce friction, like the experiment we're doing today. We're gonna build a hover disc, and it's very easy. You take some cardboard and cut it into a circle, just like this. Then put a hole in the middle of the circle. You might want an adult to help you with that. And then take a plastic drink bottle cap, like this. I like to use the ones that you get on sport bottles because they have a little nozzle that pops open or closed. And then you glue it around the circle and you get this. Then you need a balloon. So you blow up your balloon. I know you know that step. And then twist the balloon so it doesn't get away from you. When it's nice and twisted, you can stick it over the drink bottle cap like this, and then untwist it. And this is why I like to use the plastic drink bottle caps that come from sport bottles, because you can open it when you want. And when you do, your disc rides on a cushion of air, reducing the friction with the table, and it's almost like it's sliding on ice. You can also use CDs if you want to do a different design. Just make sure you're using CDs you never want to listen to again. We're gonna make a spool racer, and it's pretty simple. Here's all you need. You need some science ribbon. Now, if you don't have science ribbon, you can use regular ribbon, but the ribbon really isn't important. It's the spool that's important.
You'll also need a washer, elastics, pencil or pencil crayon, popsicle or craft stick, and science tape.
Science tape is the same as invisible tape, except I use this one only for science. Here's how you build it.
Break the popsicle stick so it's smaller than the diameter of the spool. Then put the elastics on top of the pencil and pull them tight, thread the popsicle stick through, and feed it all through the hole of the spool. Grab the elastics on the other side and pull out the pencil, and everything will be threaded perfectly. Then stick on the washer and thread the pencil through. Finally, tape the popsicle stick down so it doesn't move.
So there you go, a spool racer, and here's how it works. You spin the pencil around, and that twists the elastic. Now that elastic is gonna wanna unwind, right? So just keep spinning that pencil around until it's good and tight. And then when you put it on the ground, the pencil's gonna wanna unwind, but it can't because the table's in the way now, which means that the energy is gonna transfer to the spool, which is gonna turn, whoa, and it's gonna drive away. Yeah, let's try it out for real.
So why does this work? It works because the elastic is coiled, right? Yes, and because I'm putting in the energy to twist it. You see, I'm putting in effort to spin this pencil crayon around, and then when I've finished, all of my effort has been stored in the elastic. When I let it go, my energy transfers into movement. We're gonna be making one of the easiest and one of the hardest experiments to do. Here's what we're gonna make, a hot air balloon. And it's pretty easy to make, that's why it's one of the easiest experiments. All you need is a plastic bag, but not any plastic bag, the kind of plastic bags you get at the grocery store to put your fruit in. That kind of plastic is very thin, very light, good for hot air balloons. And you just wanna put 2 paper clips on the bottom of the bag to hold the bottom down. Now here's the other thing you need. You need an adult and a hairdryer. Turn the hairdryer on.
Put the heat on the highest setting and the fan on the lowest setting.
The air inside the bag is getting hotter, which means the molecules are moving faster and they're getting further apart, which means there's going to be less of them in the same space. Less molecules means less weight, and that means it's going to be lighter. The bigger the difference in temperature between the air inside the bag and the air outside the bag, the better it's going to work. So I recommend doing this outside, actually, on a cold day. When it's been long enough, turn the hairdryer off and it will float. Now it won't float very long because the air inside the bag will quickly return to its original temperature and it will no longer be any lighter than the air outside the bag. But it's definitely fun to fly for a while it lasts. Here's something fun you can do if you ever get your hands on a helium balloon. Now, helium balloons float up, not because they defy gravity, but because they're lighter than air. It's because the heavier air around it actually falls past the balloon, and that ends up pushing the balloon up. But what if this helium balloon wasn't lighter than air or heavier than air? It was exactly the same. This is what I like to do. Just take a helium balloon with a long ribbon and a bunch of paper clips, and adding a little bit of weight every time. And what we want to do is make this balloon neutrally buoyant. That means it won't go up or down, but it will be neutral. You want to check it every once in a while. Let's see, 3 paper clips is clearly not enough. 5 paper clips is, 5 paper clips is pretty close. It still might float down. So you want to take off just a little bit of weight, maybe about there. Watch this. You just take the balloon and you put it somewhere and it stays. It stays put. It doesn't go up. It doesn't go down. It's attached to nothing. Now, let's max it out. I had a big balloon and it had there. A giant balloon. And look, it's a great paper towel delivery device. Say, did you want some paper towel? Here you go. Science.